So that's Spark Streaming, sort of the legacy implementation. Going forward in Spark 2.0, they've introduced a new API called Structured Streaming in addition to the standard API. So let's talk about that a little bit because it's the way of the future with Spark Streaming. Now, like with the rest of Spark, they're pushing you toward using data sets for an API on Spark Streaming, just like they're doing with MLlib and GraphX and Spark SQL. They really want you to start using these higher level APIs because it gives Spark more of an opportunity to optimize things under the hood. So if you can think of your streaming job as a database problem, it's sort of a SQL problem, this can be a good way to do it. Now it is still an experimental status in Spark 2.0, so I wouldn't go using it in production just yet. It still has very limited functionality and it's not recommended for production use quite yet, but it will evolve quickly, and in Spark 2.1 that should all change. So how does it work? Well, imagine a data set that just keeps getting appended to forever. So you have a data set, which is basically a database, a very simple columnar data format, basically an RDD that goes on forever. And if you just keep appending data to that, that's very much like streaming data. It's very much like a D stream, right? So instead of like little chunks of RDDs being added to a D stream, instead we have rows of data being added to a data set. So same idea, just thinking about it a little bit differently. From a code standpoint, this is how it looks, and it's actually pretty neat. So once you have a Spark session object, just like you would create for any Spark SQL application, you can call read stream instead of read. So let's say that you have a bunch of structured JSON data going into a big S3 folder, like S3 logs is the name of the bucket, let's say. You can actually call read stream to just sit there and listen for new log files being added into that directory. And since it's in a structured format, a JSON format, it can import that directly into a data frame and understand its schema and the type associated with that data. So this is exactly the same code that you would write to do a non-streaming application, except instead of read, we're doing read stream. Okay, so it's very easy to convert a non-streaming application to a streaming application using the structured streaming API if you're using data frames. And once you have that data frame in place, it's just getting appended to over and over and over again. You can say things like this. I can say input.df.groupby. So let's say there's an action field and I just want to add up all the different action types that occur within a 1 hour window. That's what this does. So I can actually say group all the action codes together, have a 1 hour sliding window, and count them all up every hour. And I can actually keep writing that data out to a JDBC database at a given path, and that will automatically do the right thing. So a couple of things worth mentioning here. First of all, we can actually specify what column we want to order things by. So unlike with a D stream where Spark Streaming is kind of deciding what goes into each individual RDD that gets added to the D stream, you can say, I want to actually add things in order as they come in based on a column in a data frame. So, if you have a column in your data frame that's like hit time or, order time or something like that, you can use that and actually do your window based on that explicit column, and then you can get a guarantee that things will be processed in the correct order. So that's kind of a powerful thing. Also, it can automatically keep track of what's come in, what's changed, what's new, what's different. So this is going to keep appending to your database all the changes that come in, and it can keep track of fault tolerance and all that stuff for you. So it's a very simple API, but it belittles its complexity under the hood. So it makes it very easy to write what they call continuous applications. That's kind of the new terminology for a Spark streaming script, continuous applications, where the idea is you can take a data frame-based application, just change a read to a read stream, add a couple of lines at the end of the code to kick off that stream and keep monitoring it, and you're done. You have a continuous application instead of a batch application. So that's structured streaming in the way of the future.